Now, the fun part of matrices is using it for cryptography. So, matrix inverses provide a simple and effective procedure for encoding and decoding messages. So, basically, we're going to set each letter of the alphabet assigned to a number 1 through 26 with 0 assigned to a blank space for basically spaces between words. All right, now, of course, more sophisticated coding can be done, but this is just kind of the basic, something we can do for a class. And so, again, blank is 0, then we have 1, 2, 3, 4, all the way down to Z is 26. Okay. Now, let's say we have a message called secret code, and that's going to correspond to what? Well, we look up S, and that's 19. We look up E, that's 5. And as we go across, we've just translated this into this. Okay. Now, this is going to be what we convert now into a matrix. And so what we're going to do is any matrix whose elements are positive integers and whose inverse exists can be used as an encoding matrix. So it doesn't matter. In this case, we're going to use A is 4311 is going to be used as our encoding matrix. Okay, so they can give you any kind of matrix to do this for encoding. It doesn't matter. And what we're going to do is we're going to divide that sequence for secret code, which was found using the letters, into two groups and use these groups as columns of matrices with rows proceeding down the columns. Okay, so not across, we're going to go down. So it's going to go 19, and then below it's 5, then 30, 18, 5, 20, kind of like here. So we're just going to keep going down as we go across. And then a space again is 0, and then 3, 5, 15, 4, 5. And then if there's empty space left over at the end, we need to add a 0 there. Okay. Now, if this had been a 3 by 3, then we'd have a 3 by whatever it ends up being. So it'd be 19, 5, 3, and then 18, 5, 20, and then 0, 3, 15, and then 4, 5, 0. Okay. So it's all going to depend on what your encoding matrix looks like. So that's our B. And now, again, it shows the blank at the end to make the columns come out even. Now, what we're going to do is we're going to multiply the matrix, this matrix we just found, on the left by A. So we're going to take A times B basically. So here's our A they gave us as the encoding matrix. We're going to multiply it by B, which was our secret code, and we're going to come up with this new matrix here. Okay, so that's going to be our code. So the code message then would come out 91, 24, 66, 21, 80, 25, 9, 3, and so on until we got done. Now, so that's our code we're going to send out, to whoever we're sending it to. Now, this message can be decoded by putting it back into the matrix form and then multiplying on the left by the decoding matrix, which is the A inverse. So, let's say, for example, this is our message. It was encoded with this matrix, and we want to decode it. So we're not going to decode this one because we already know what it does. So we're going to get a new one, and we're going to say decode it using this. Well, first we have to find out what A inverse is. So the encoding matrix A is 3 by 3. So we begin by entering the coded message into the columns of a matrix with 3 rows. So we have to have 3 rows. So when we do that, we just 46, 84, 85 first column, then 28, 47, 46 next column, and we just keep going all the way down until we get to the end. Okay. Then B is the matrix containing the uncoded message. B and C are related. C is equal to AB. And so what we have to do is we have to find inverse of A. Now, that's easy, because what we can do is we can plug that into our calculator, get A inverse, and then after that, we can multiply that by this C also in our calculator if we wanted to easily. So really, we could plug in A, we could plug in C, and then we could say, okay, type in this in our calculator, A inverse C, and it would automatically do this problem and give us this out. Okay. Now, that means we're going to have 3 letters, then it looks like a blank, then 2 letters, then a blank, then 1, 2, 3, 4 letters and a blank, then 1, 2, 3, 4, 5 letters and a blank. And so that's what it's going to be. Now we just have to make these letters equal to whatever they are in our thing with A being 1 and so on. And so again, that's our decoded message. And so 23 is a W, 8 is H, 15 is O. And then we have a 0, which is a space, and then 9, I, S, blank, Carl, space, Gauss, space. Okay. And so who is Carl Gauss? And so that's going to be our decoded message. So again, a lot of this cryptography can be done, if we know A, well, actually, if we know A and we know C, then we can take and do in our calculator and just type it in A inverse C and we get out our matrix, immediately we can decode that using our key and we get who is Carl Gauss. All right, so hopefully that will help you with some examples in our book.